All right, let's think about nondisjunction. In nondisjunction, we have a failure of the normal meiosis divisions, the normal divisions of meiosis. And here we have a cell. I've indicated an X chromosome and a Y chromosome. So this is a male cell. It's preparing to enter meiosis. So it's going to undergo the S phase, and it'll make a copy of its little green X and a copy of the little green Y. I've made their centromeres both white, so to remind you that these are homologs. So they pair up in prophase 1 of meiosis and then head to the metaphase plate. So here they are, ready to go through the first division of meiosis. During that first division, you'll remember what normally happens is the homologs separate, the Y would go to one pole, and the X would go to the other pole. If we have a nondisjunction in that first meiotic division, however, they will both go to the same pole. So now I have an extra chromosome in one of my cells, and I'm missing a sex chromosome in the other. So these will finish up telophase, they'll start prophase 2, and then head on to the metaphase plates for the second division. So now I have 2 copies of my sex chromosomes in one cell, and I have no copies of my sex chromosomes in the other cell. I have the other 22 autosomes in each cell, so this is going to continue through meiosis. And as you'll recall, in the second meiotic division, the centromeres duplicate, and sister chromatids move to opposite poles. So in this case, one green and one red, one green and one red will move to one pole. No greens, no reds, no greens, no reds will move to the other. This will form the 4 nuclei. They usually do 4 cells, 4 new sperm. And these 2 sperm have no sex chromosomes in them. When they fertilize an egg, that egg, can I write it upside down? I'm not sure. That egg will have, there we go, that egg will have an X chromosome from the mama and be fertilized by a no sex chromosome bearing egg from the dad. That will give rise to an individual with an XO sex composition, and that little girl will have Turner syndrome. The other sperm will have 2 sex chromosomes in them. So if those fertilize an egg with an X, as they are probably going to do, then that egg would have 2 X's, would have 2 X's and a Y. Let me turn my Y upside down. 2 X's and a Y, and that would be a little boy with Klinefelter's. I don't know if I can write upside down. Klinefelter's syndrome. Okay, so that's a first meiotic division, nondisjunction. The problem is that first meiotic division when homologs separate. But we could also have a problem coming from the second meiotic division. So here's that original cell. It's getting all ready to go into meiosis. So it's going to undergo an S phase. Let's get some sister chromatids in here. Here's my X chromosome made up of the 2 sister chromatids. Here's my Y chromosome made up of its 2 sister chromatids. They're going to pair In prophase 1, they're going to head to the metaphase plate in metaphase 1, and we're going to have a normal meiotic division, so the X will go to one pole, the Y will go to the other pole. We'll separate this to make 2 nuclei, and now we're going to get ready for our second division of meiosis. And in the second division of meiosis, either one of these could fail to separate. So if my X's fail to separate, or they both go to the same pole, I will end up with a sperm that has 2 X chromosomes in it. I'll have another sperm that has no X chromosomes in it. Similarly with my Y, if for some reason those both went to the same pole, there we go, and nobody goes to the other pole, I'll end up with a sperm with 2 Y chromosomes in it, or with no sex chromosomes in it. So, in the male, if I have a failure of meiosis at the first meiotic division, I'll get a sperm with an X and a Y, because at that point the homologs failed to separate. If the non-disjunction is in the second meiotic division, I will get a sperm either with 2 X's, or I could get a sperm with 2 Ys, depending on which 2 sister chromatids failed to move to opposite poles. I can get an empty sperm, no sex chromosome sperm. It's not empty, it's got the 22 autosomes. It's a no sex chromosome sperm from either non-disjunction in meiosis 1 or non-disjunction in meiosis 2.